Hey everybody, so we are talking about ionic and covalent bonding. We're going to do ionic bonding first. And the first question is, why are they even created? And just like the question that was asked at the very beginning, the answer has to be the word stability. Okay? Remember, all elements want to be like the noble gases. They want to at least have a electron configuration like the noble gases. So the idea is ions form when atoms become charged. Some elements gain electrons, and we call those anions. And anions usually form on the right side of the periodic table. Atoms that lose electrons are called cations, and they normally form on the left side. Okay, so the anions, when they become charged, the reason why they get charged is because they again want to become just like the next noble gas, which is at the end of that row. So let's talk about fluorine first. We know that fluorine, and I'll do it over here, has a electron configuration of 1s2, 2s2, 2p5. Now we know that fluorine is not filled because you can see there's only 7 valence electrons there. If fluorine gains another electron, then it becomes like neon, and neon is 1s2, 2s2, 2p6. And you can see that neon does have a full valence shell. Neon's is now stable on every single energy level that it has. When fluorine gains this extra electron and becomes like neon, it becomes the fluorine ion with its F -1, 1 negative. All right, let's look on the other side. When we talk about the cations, it normally happens over here, most of the time from these two brightly colored groups, but it also works all the way. Cations are also found going all the way across almost to this stair-step line. And the one I want to talk to you about today and do something with you guys today is going to be the aluminum. All right? Aluminum is 1s2, 2s2, 2p6, and since it's on the third row, we are talking about 3s2, and it's the first one in the 3 p's. So aluminum has as valence electrons 3s2 and 3p1, which is only 3. So the first energy level and the second energy are stable, the third energy level is not. Well, aluminum is going to lose back 1, 2, 3 to become the noble gas right in front of it, or in front of it on the row above it. That's also neon. So when that happens, the aluminum ion, or the aluminum ion that is formed, is just like the noble gas also, because look, these guys are gone, and what do you see here? But you see neon's noble gas form. All right? So when electrons lose, or elements lose electrons, they become, as we said, charged. That is only the first part of the challenge that they come across. The other one is going to be that they are now attracted to other elements that have, if they lost, have gained. So we're going to talk a little bit, watch a little video, and then I'm going to be right back. Okay, so this is a 2-minute and 41-second video by Tim and Mobley, and they're going to do a little bit of discussion with you with regard to forming of ions and remembering maximum number of valence electrons, and so on. So again, it's about 2 minutes and 41 seconds.
How come there's never any salt? Dear Tim and Moby, I have to do a project about ions. Can you tell me about them? From Caitlin. Hey there. An ion is an atom that has an electrical charge. Yeah, we should probably do a quick review of atoms. You probably know that atoms have a nucleus made up of neutrons and protons. Protons have a positive charge, and neutrons have no charge. For every proton, an atom has one electron, a negatively charged particle that orbits the nucleus. Because of the equal number of electrons and protons, atoms have no charge. The negative electrons and positive protons cancel each other out. But if an atom loses or gains an electron, and that balance is lost, and the atom becomes a charged ion. Well, an atom's electrons orbit the nucleus in energy levels called shells. Each shell can hold a certain number of electrons, starting with 2 in the first shell, 8 in the second, and ending up with a maximum of 32 per shell. The outer electron shell is called the valence shell. Atoms like to have a full valence shell. So atoms with nearly empty valence shells will often give up their valence electrons, becoming positively charged cations. Atoms with nearly full valence shells often take on extra electrons, becoming negatively charged anions. That's why atoms that like to lose electrons are said to have positive valence, and atoms that like to gain electrons have negative valence. On the periodic table, positive valence atoms tend to be grouped on the left. On the right side of the table, atoms tend to have a negative valence. Let's look at a specific example. Whoa, deja vu. Anyway, sodium has 11 electrons, giving it 1 valence electron. It doesn't take much energy to knock off that lone electron, which means that there are a lot of positively charged sodium ions floating around. Chlorine has 17 electrons, with 7 valence electrons instead of a complete 8. So it likes to scoop up an extra electron, resulting in negative chlorine ions. Since the two ions have different charges, they're often drawn together, kind of like two poles of a magnet. Yep, they become the uncharged sodium chloride, table salt. The ionic bond holding salt together is pretty strong when it's on your table. But as soon as it's put into water, the electrical forces in the water dissolve the bond. Is that where all the salt is going?
All right. So Tim and Modi, we're talking about forming ions and how that happened. But the one thing they didn't do is they actually talked about the fact that it formed NaCl. What they did not, or what I'd like to, I guess, focus on is the idea that ionic bonding is a two-step process. This is one of the big ones that for me needs to be done as quickly as possible. The first one is gaining or losing electrons. These are not events that have to happen together. In fact, sodium can lose its electrons way over here to the left, and chlorine can be clear over here to the right where it gains its electrons. Sodium doesn't give its electrons to chlorine. Chlorine doesn't give its take its electrons from that. It's a two-separate process. These two are separate events. All right. So the second step is that these ions that are formed occur as a second step. They're ions, they bond with each other because they have opposite charges. This happens second, okay? And it's really important that we actually pay attention to that. As we move into the next area, which is going to be covalent compounds, or covalent bonding, we need to do a quick little comparison before we ever get started. Ionic bonding is between ions. Okay? Covalent bonding is sharing electrons. Now I'm going to leave this up here because what we need to be able to do is I need you to get that covalent bonding is a single step process. And so there's a couple questions that I ask about this every single year. And once you've watched this next video, which is about 3 minutes, you'll be able to hopefully make a little bit more sense out of what I'm getting ready to ask you, okay?
Okay, why do atoms bond with one another? Well, they bond with one another to become stable, and what that means is that they are trying to obtain more electrons so they can fill their levels. Now, there are two basic types of bonds, and that's why you're watching this video, is to learn the difference between the covalent bonds and the ionic bonds. Let's go over covalent bonds first. Okay, so the basic definition of a covalent bond, it's a bond between atoms where they share electrons. And so the goal of atoms forming covalent bonds is to become stable, to fill their levels of electrons. And a classic example of this is oxygen, the oxygen that we breathe, O2. The oxygen that plants make by doing photosynthesis is actually two atoms of oxygen stuck together. So let's look at oxygen. From the periodic table, it's got 8 protons, it's got 8 neutrons. So let me draw oxygen number 1. I'll get to oxygen's electrons in a moment. So in the nucleus of oxygen number 1 are going to be 8 protons and 8 neutrons. Well, I'm also going to draw the electron levels around the nucleus, and now I can tell you that oxygen has 8 total electrons. So when I draw the electrons, I'll put 2 electrons in level number 1 because that's all level number 1 can carry. And then I'll put the leftover 6 electrons in level number 2. And notice how the first level, the inside level, is stable because it can only hold 2, and it has 2. But the second level is unstable. It can carry 8 electrons, but it only has 6. That's a problem. It's unstable. Well, the oxygen that we breathe is actually made from 2 atoms, so we have to draw a second oxygen atom. Like the first, it has 8 protons, it has 8 neutrons in the nucleus, it will have a couple levels for the electrons, and it's got 8 total electrons, so just like before, I'll put 2 electrons in level number 1, I'll put the remaining 6 electrons in level number 2. So the first level is stable, it's filled. The third level is unstable, it's not filled. It doesn't have 8 electrons, it only has 6. So what's going to happen when these 2 atoms are both unstable? Well, in this case, they're going to form a covalent bond. They're going to overlap their electron levels and share their electrons. So when you count up the electrons of oxygen number 1, 1, 2, level number 1 is stable. How about level number 2? Level number 2 has 1, 2, 3, a shared 4th, a shared 5th, 6, 7, 8. Level number 2 was once unstable, but it is now stable because of the sharing of electrons. Let's look at oxygen number 2. Oxygen number 2 has 1, 2 electrons in the first level stable. Look at the outside level. 1, 2, 3, 4, a shared 5th, 6, 7, a shared 8th. Because they're sharing electrons, oxygen number 2's outside level is now stable. So if I set those electrons in motion, those shared electrons are zigzagging back and forth kind of like in a figure 8 right here. And because of this sharing of electrons, both oxygens, oxygen number 1, oxygen number 2, they have filled outside levels. That's a covalent bond. Let's look at...
Okay, so when I left you, I told you I was going to talk to you about the difference between the ionic and covalent bonds and the fact that this is a 2-step and this is a single step. If it's a single step process, then what you need to get is stability and the bond occur at the same, sorry you can't read that, at the same time. The bond forms in order to make both elements have a stable valence shell, right? So stability in the bond occurs at the same time. When you look at ionic bonds instead, what you see is that stability occurs from step number 1. Stability, again, remember, is stability equals a full valence. Okay? So in covalent bonds, full valence shell happens as the bond occurs. That's the purpose of the bond. In ionic bonding, stability occurs when elements gain or lose electrons. Bonding of ions with each other reduces, eliminates charges. Ionic bonding does not reduce or does not stabilize atoms. What it does is it takes the charges away. All right? So there's an awful lot more we've got to do, but right this very second we're going to stop and we're going to say this is it. There is a power, this is going to be on an ed puzzle, and you're going to have a bunch of questions to answer, and this will be your assignment for today. All right, thanks guys. See you soon.